Have you ever wondered why some truck tires never touch the ground or why U.S. vehicles are behind European trucks in horsepower? Come along as we investigate the mystery surrounding extended wheelbases and the diminishing usage of V8 engines in semi-trucks. Learn why stick shifters are going extinct in the trucking industry as well. Prepare for a brief but entertaining journey through the interesting trucking world in this combined video. Number 1. Why U.S. manufacturers stopped making V8 semi-truck engines? Imagine yourself driving down the highway in the 1960s, when V8 engines graced semi-trucks like the International Transtar 430, Peterbilt 359, Kenworth LU 900, Mack E9, and Freightliner UFT. The robust Cat 3408 V8, manufactured in the 1970s, was unrivaled during that period and stayed that way until it was phased out in 1985. Despite becoming out of style, the Cat 3408's sustained success in construction, power generation, and maritime vessels is proof of its enduring prowess. The landscape of semi-truck engines has changed dramatically in the modern period. The efficiency of inline-six engines has been welcomed by the industry, and manufacturers have noted that the engine's longer strokes produce more torque. This technological advancement has led to the development of powerhouses like the Detroit DD16 and Cummins X15, which have amazing numbers of up to 2,050 pounds per foot and 605 horsepower. The American trucking business no longer needs V8s due to the development of contemporary inline-six engines, especially with the government's 80,000-pound weight restrictions. However, in response to the unique needs of countries where weight limits exceed 200,000 pounds, European truck maker Scania continues to produce V8 engines that can reach 770 horsepower and 2,730 pounds per foot of torque. Due to their longer stroke and increased torque output, inline-six engines have taken the lead in the market and are revolutionizing the way that efficiency is perceived. These engines are groundbreaking because they run at lower RPMs and still give excellent performance and significant fuel efficiency gains, an essential feature for long-distance applications where fuel economy is critical. Reduced operating costs are one way that trucking companies can profit economically from the inline-six lower fuel consumption and less servicing and maintenance costs. Due to its streamlined design, the inline-six engine runs more efficiently and has less downtime since essential engine components like camshafts and injectors are easier to reach. However, because of its complexity and increased number of parts, V8 engines are more expensive to purchase new and require more frequent maintenance. The streamlined profile of the inline-six, with its longer and thinner design, prioritizes ease of installation and maintenance, maximizes available space, and integrates more easily into the truck chassis. The U.S. moved away from V8 semi-truck engines as a result of tighter emissions regulations and mounting environmental concerns. Manufacturers turned their focus to inline-six engines, which offered superior fuel efficiency and emission control systems, in order to comply with rigorous rules. One of the best examples of this shift is the well-known engine manufacturer Caterpillar, which shifted its focus from manufacturing semi-truck engines for use on roads to manufacturing industrial diesel engines for less regulated industries, including mining, construction, and agriculture, in 2010. As pollution regulations rise, a wealth of alternative options have also surfaced, including gas trucks, electric trucks, hybrids, and cars powered by hydrogen. Even though they operate with reduced or no CO2 emissions, the process of making them can produce emissions that are far higher. Politicians and nations seem to be missing the irony. Let's move on to the fascinating tale of why automakers stopped making V8 semi-truck engines. It will be disclosed in the next section. Put it down to the inexorable hold of emissions regulations, a need for more fuel economy, financial concerns, and the knowledge that the powerful V8 may be more powerful than necessary given the proven competence of inline-six engines. The trucking industry has come to rely on these six-cylinder powerhouses due to their widespread usage, prompt component availability, and show effectiveness in long-distance transportation.
If you're enjoying the content so far, please don't forget to subscribe for more amazing updates, like the video to show your support, share it with your friends, and leave a comment with your thoughts below. Your engagement helps us create even better content for you.
Number 2. Why trucks have such long wheelbases? The basic measurement of a truck's wheelbase is the distance between the front and rear axle centers. This seemingly simple measurement has a big effect. The unsung hero that drives a truck's performance, comfort, stability, and handling on the road is this dimension. Whether the wheelbase is expressed in inches or centimeters, depending on your region and preferred unit of measurement, it's more than just a number. It's the unsung hero that decides how smoothly a vehicle drives on the road. Now let's talk about the amazing range. The wheelbases of American trucks vary from about 140 to over 300 inches. Some giants are made specifically to elongate over 300 inches in order to support tasks like pulling heavy loads or intermodal containers. A thorough approach that considers axle configuration, cab size, and usage is wheelbase selection. Go back in time to a period when long-haul trucks developed into the massive vehicles they are today. Around the middle of the 20th century, regulations on truck lengths made it impossible for trucks to have large wheelbases. The rules of the game were changed in 1982 to remove all restrictions and permit longer cabs. Prior to this, cabover trucks were commonplace. They were compact and nimble. As industries grew, longer wheelbases were required. Large, long-nosed trucks gradually supplanted the cabover during the 1980s. With the construction of the U.S. interstate highway system, longer wheelbases became necessary for quick, cross-country travel. This modification increased comfort while transforming hauling efficiency and enabling larger loads with unshakable steadiness. Longer wheelbase vehicles are more stable, especially when traveling at higher speeds. For this reason, they are the best choice when hauling big or heavy loads. The stretched design is not only aesthetically pleasing, but it is a well-thought-out choice that ensures ideal weight distribution. This increases overall road safety by extending the life of road surfaces and reducing the stress on certain axles, tires, and suspension components. Long wheelbases are necessary for towing bigger and heavier items in industries like construction and heavy machinery that rely on bulk transportation. However, a smoother and more enjoyable journey benefits both drivers and passengers, so it's not only about the goods. The longer distance between axles functions as a cushion to absorb vibrations and irregularities in the road, making long trips easier. Large sleeper compartments are an added bonus for truck drivers who travel great distances. During overnight stays, they offer a cozy haven that encourages driver well-being and adherence to mandated rest periods. When it comes to cars, every advantage has an equivalent. Even with the incredible advantages, there is a drawback to the circumstance. Longer wheelbases reduce mobility, which makes turning more difficult and problematic in small areas. Building projects in urban jungles become obstacle courses, and parking spaces become prized commodities. The blind spots in the elongated frame add another degree of complexity, making reversing harder work. In uneven terrain, long wheelbase vehicles may have trouble and encounter impenetrable obstacles, which may slow them down. While the extra length boosts cargo capacity, it also requires reinforcement in the construction, increasing the truck's overall weight and perhaps making it more difficult for it to climb steep inclines. Number 3. Why European trucks have up to 770 HP and US don't. The twist is that there's an epic torque fight going on between the US contenders, with their formidable pound-feet, and the European trucks with their Newton meters. It seems as though the European trucks chose to embark on a horsepower journey in order to get away from the monotony of 500 horsepower or such. Rumor has it that these European truck manufacturers have a secret agreement to outperform each other in the horsepower battle, confusing their rivals in America. The mystery is exacerbated when you discover that, in contrast to the United States, where businesses participate in a crazy mix and match extravaganza employing engines from various manufacturers like Packer, Detroit, and the like, every truck company in Europe produces its own engines. What was the result? An order of horsepower that makes one wonder. Should American trucks finally join the horsepower extravaganza in Europe? Who wouldn't like to see an American truck with its astounding 770 horsepower under the hood displayed so proudly? Ultimately, European automakers like Mercedes-Benz, DAF, Volvo, Renault, and MAN take great pride in showcasing their potent engines, which range in horsepower from 440 to 640. These engines are claimed to share more parts and technology than a family picnic and potluck dinner. Volvo, Mack, and Renault having a nice little get-together to share engines, DAF cruising around with a Packer engine, and the Daimler Group commanding Mercedes-Benz, Triton, and Detroit like puppets. But there's a cliffhanger. The Volvo 16K with 750 horsepower and the Scania V8 with an incredible 770 horsepower are expected to debut a joint engine spectacular in 2024, presented by the Triton Group, the proud parents of both Scania and MAN. The truck engine equivalent of superheroes is being embodied by the European heavyweights Volvo and Scania. Many people are unaware that the United States, with its extensive road infrastructure and legal weight restriction of 80,000 lbs for semi-trucks, adheres to a practical philosophy. This is the peculiar dance between absolute necessity and weight constraints. The 500 horsepower engines are more than capable of navigating the terrain of America, so they don't require extra power. Here Europe, a continent consisting of 27 distinct countries, tells a special tale. A difficult environment is created by the various weight restrictions, which range from 60 to 90 tons in different countries. Steep climbs and large loads necessitate massive engines, such as the astonishing 16.4 liters Scania engine with an astounding 770 horsepower. This is an amazing demonstration of engineering brilliance motivated by necessity, where every horsepower becomes a vital instrument for negotiating Europe's treacherous roads. Number 4. Why do some truck tires do not touch the ground? These axles, which are connected to the wheels by bearings, are crucial components of any automobile. The differential and axles are moved by the drive shaft, which is turned by the transmission and engages when the engine begins. Trucks are equipped with a variety of axle types, including steering axles at the front that facilitate easy maneuvering and driving axles at the back that allow the vehicle to go forward. Nevertheless, the riddle surrounding non-grounded tires is revealed by the mention of lift axles. These axles can be raised or lowered to increase traction or fuel efficiency. They are ideally placed in between the drive axles. The axles can be lowered to allow the weight to be appropriately distributed among multiple axles once the vehicle is fully loaded. This lessens the deterioration of the road and enhances traction and grip, especially in challenging weather conditions like rain, snow, or ice. By modifying the cargo weight distribution using the lift axle function, drivers can make sure that their load complies with applicable legal weight regulations in different jurisdictions. Regulations have additional benefits related to fuel efficiency. Lowering the axles while not in use reduces rolling resistance, boosts fuel efficiency, and saves operating costs. Elevating axles when not in use can extend their lifespan and reduce total maintenance costs. Lift axles increase stability and braking power, reducing the likelihood of collisions. Safety comes first above all else. Axles that are fully integrated into the truck's air suspension system can be easily controlled by a switch within the cab. When the switch is pressed, a burst of air is pumped into the airbags beneath the axle, forcing it to rise gracefully off the ground. This feature increases fuel efficiency by lowering friction between the tires and the road and is quite helpful when the truck is running light or empty. When the switch is turned off, the air is released, allowing the axle to descend smoothly. This function helps to improve handling and stability by distributing the vehicle's weight, which is especially crucial when the truck is fully loaded. Long-haul trucks, dump trucks, and construction vehicles all frequently use liftable truck axles. The way these massive vehicles traverse the road has been totally altered while yet striking the perfect balance between efficiency and stability. Number 5. Why trucks with stick shifts are going extinct. In this dynamic climate, truck manufacturers offer a variety of equipment programs that add a personalized touch to maneuverability, fuel efficiency, off-road exploration, and other features. Manual gearboxes, with their tactile appeal, let a truck driver hone the art of selecting the right equipment. A difficult tango between the demands of the terrain and the cargo. These transmissions are sometimes inexpensive, even when operating them. Nonetheless, they still need to be operated by a maestro, a skilled craftsman who understands the nuances of the road. Consider a truck with 12 or 24 gears, each of which would stand for a note in a composition where split ranges redefine the melody. It's evident that manual enthusiasts, who deride automatic cars as belonging to the uneducated, are ecstatic. But in this tale, technology emerges as a silent hero, introducing dual clutch systems that seamlessly synchronize gear changes and dispelling the myth that simplicity equates to an ineptitude. This revolution began in 2002 when Volvo introduced its iShift technology, and nearly all truck brands have now joined the automated gearbox bandwagon. The advantages are undeniable. As your dependable copilot, the truck's onboard computer automatically chooses the optimal gear for the road conditions, weight, speed, and temperature. You can disregard stumbling over a clutch. By sparing up to 3% of fuel annually, this increases fuel efficiency and ensures a precise and seamless gear shift, hence reducing gearbox wear. The truck switches smoothly between gears, allowing you to focus entirely on the road. This increases your control and awareness, two crucial factors in reducing accidents. We are grateful for your companionship on this fascinating journey as we come to the end of our trucking odyssey. It's been an adventure of curiosity, from floating tires to tales of horsepower and changing up. May your paths flow freely, your gears run smoothly, and your interest never dies before our next adventure. Happy trips!